I'm Conrad. I'm one of the maintainers of Pry, and today I want to talk with you guys a bit about REPL-Driven Development. So REPLs have been really popular since the Lisp days, the 1960s, that's a long time ago now, when they realized that there's not much difference between the data in your program and the code that your program is running. So wouldn't it be nice if you could just take a string and then run it as though it were code? And that gives you the eval function, which is the core to making something like a REPL work. So in Lisp days, they had this, they had a REPL, and the idea is that you read in a line from the user, you run it, you eval it to see what it does, print out the output, and then you just loop around to start again. And all the modern scripting languages, so Python, JavaScript, Ruby, they all have an eval function, and they all have REPLs built with that. In Ruby, building a REPL is really, really easy. It looks exactly like it says on the tin. You just read a line, eval it, puts it, and loop back around again. And indeed, like IRB ships with Ruby. It's based on this principle. They've added a bit of fluff to make it work better. But under the hood is this one line of code that's powering IRB. It's exactly the same line of code that started, Pry started exactly the same. Pry is a REPL. Started with this line of code, and then the first Git revision is about 75 lines that wrap this to make it better. So John Mayer was the guy who originally created it. He's at Bannisterfiend if you want to follow him on Twitter. He's kind of cool, writes developer tools all the time. So we started from this one line of code. Git revision 1 was 75 lines of code. And because nothing ever gets smaller, we're now at 12,000 lines of Ruby, which is a lot. But we've done quite a lot to improve on this. So there are about 3 major areas in which Pry beats this one line. Firstly, and most obviously, if you look here, if you do anything wrong in that read line and it crashes, the entire REPL just falls apart, and you have to restart it and go from scratch. So Pry will catch exceptions. It will tell you what's going wrong, and it won't make a fuss about it. It's not like a massive stack trace. It's just, hey, you had an exception. Maybe you want to try again. We've also made it so if you want to define a method, if you want to do something that takes multiple lines, you can do that. So robustness is something we've really worked on. We have about 4 million downloads now, so everyone is hammering it. Pry just kind of works out of the box. The second major area we've improved is making it fun and easy to use. So the one line there is just puts. We do kind of pretty inspection. We do syntax highlighting, both input and output. We try and make it really easy to read what's coming out. We've also added things like tab completion. IRB has a bit of tab completion. Pry takes that to the next level, just to make it easy to interact with. You don't need to always type everything out correctly, just tab complete, and that will fill in method names for you. And the third way in which we've improved Pry is we've added introspection commands. So Ruby is an awesome language. It has all kinds of dynamic features for looking around and seeing what your program is doing. The most obvious one of this is if you call the class method on an object, it says, I'm this class. So you can get active record base, or you can get whatever out. And there are other more complicated ones, like .methods will give you the list of methods that you can call on an object. Pry knows all about all of these things. It knows all about the bugs and the edge cases in them, and it wraps them up and tries to make them easy to use. And so a big part of the later bit of this talk is going to be demonstrating how Pry commands can help you explore Ruby programs without having to go through so much effort yourself. The question you should all really be asking, though, is 12,000 lines of Ruby, that's a lot. And it is. Why did we, there's like 4 or 5 of us on the core team, there's 30 or 40 people who have sent pull requests. Why was it worth doing that instead of just using the hacky one line whenever we needed it? And the answer, I think, is REPL-driven development. So the idea is kind of similar to test-driven development. Don't write code first. And with REPL-driven development, it's not even writing tests, so don't write tests first. Instead, work out the code you're going to write using a REPL, and then start documenting it and writing it down properly. And the reason for doing this is that if you're in a REPL and something goes wrong, it takes no time to fix it. You can just loop around and loop around. And so once you've used a REPL, the chances are the line of code you've written actually works, which you can't say if you've just added it to a text editor. So test-driven development is very much about maintainability, about writing nice APIs. REPL-driven development is about writing code that works first time, or making it way, way faster to get to working code. REPLs are so awesome that you can even find celebrities like Spock using them. That's the only way to make code perfect. So as a developer, I have a kind of a problem, and I hope that you all share it with me, otherwise this is going to be quite embarrassing. But about 80% of the time, if I write down a line of code, it crashes. This is usually for something really, really simple. I have a typo, I've spelt the method name wrong, or I've just missed a plus, I'm doing the wrong maths. And this is kind of unacceptable. If I pushed code out and it crashed 80% of the time, no one would use anything I'd written. And you can see that really clearly when you look at GitHub's status page. So they actually publish how crashy GitHub is. When I was writing these slides, they crash on about 0.0008% of requests. What makes that number so astounding is that GitHub isn't just one bit of code anymore. There's probably thousands of method calls or thousands of chunks of code that go into serving each request. And if you multiply those out, that kind of works out at each method call on github.com has a failure rate of about 8 in a billion times. And that's embarrassing for me because that's about 100 million times better than what I manage. So what do I do to fix this? Well, 3 simple things. If you run the code, that will tell you about all the typos. That will tell you about all the stupid little things that you've just got slightly wrong. It's very quick to do. You just run the code, and then you have reasonable confidence. That's one of the reasons that test-driven development exists. It ensures that you've actually run the code before you deploy it. The other things you can do, you can read the code around that. So if you're working on an application, each line of code isn't in isolation. You're calling methods. There are methods calling you. If you just read those methods, the chances are you can get a good idea for what the code you're writing should expect. You can see how other people are handling nils in the surrounding code. You can get a feel for how your code should be written to work the best. And so it's not as good as running the code. I mean, if you run the code, you have a very high degree of confidence that it works, but it lets you get another level better, or one further level down the line. And it's also reasonably quick to do. Reading a few methods doesn't require understanding the code. You're just looking around to see if you can spot anything obvious. Understanding the code is kind of the end goal. If you can write code in a code base that you completely understand, you can probably get away without running it. I mean, you should check for typos and things, but the chances are, if you fully understand your code base, you're not going to make silly mistakes, or you're going to make them less often. And so, like, the ideal goal for everyone should be to understand the code, but the obvious problem is that can literally take forever. If you're in a large Rails app, there's the whole of Rails. I don't know if anyone has the whole of Rails in their head anymore. And any app of substantial size will be tens of thousands of lines of code. It's going to take you days or even months to understand that stuff. So I tend to leave the understanding the code until the first 2 approaches have failed me. I'll run the code. It will take a few seconds. I can just iterate on that a few times. I'll read the code around if I need higher degrees of confidence. So if I'm changing something deep in our data layer, and I'm like, this could be dangerous, I'll start reading around and checking that my assumptions are lining up with the assumptions in the rest of the code. And this doesn't take me very long. It takes me particularly less time because I use Pry to do it. And this is where everything ties together. If you have a REPL, it makes it really, really fast to run code. You literally just paste it in, run it, done. Pry has features that make it really, really easy to read code as well. You can just look at a method, and it will tell you the source code. I'd like to think that it helps with understanding as well, because if you can inspect your program while it's running, it's easier to understand. But I've noticed for myself that if I need to understand a gem, I'll get clone it. So Pry still has some way to go there. And what I'd like to do now is just show you a little bit of how Pry works. This is going to be embarrassing because I'm going to deliberately make mistakes on stage so that I can debug them. So opening Pry is just like IRB. You just type in Pry. You have to have gem installed it first. And this is a task I had to do when I started my new job. So I started a new job a few months ago. We're using Mongo. Before, I'd only ever used Postgres. So I was like, what's this thing? What do I do? So all I know is there's this global database, $Mongo. It's just a Ruby global variable. And you can see here how Pry's already starting to help. So we've got dark green for globals. It's like, maybe you shouldn't be using those. Then classes are blue, and strings, et cetera, et cetera. So you can see that this Mongo object is actually a moped session object. Well, I have no idea what one of those is, but I can look it up really easily. I don't need to go to GitHub. I don't need to go to Google and try and work it out. I can just type $$Mongo. The full name for this command is showdoc, but why would you ever type 8 characters when one will do? So $Mongo is going to look up the documentation from moped session and then show it to me in the terminal. And you'll see that took no time at all. Why? Because Ruby code, it's all local. It didn't have to go to the internet. It's just all there. And so if I skim read this, I can see that a session in moped is the root for all interactions with Mongo. It can talk to a single database or dynamically multiple databases. But what I'm interested in here is this example. It's like, here's how to use Mongo. This is exactly what I want. So I want to find a user in the users table. I want to look up my user. So I have an admin user, and I want to just find it. And so this should be easy to do. I can just ask Mongo for its users collection, and then find the one that has the name of Conrad. And that didn't do what I wanted. Why not? I don't know. So let's have a look at the find method and see what it's actually doing. So just like $mark is for showing documentation, $ is for showing source code. That's also show source if you type it out fully. And if I run that, I can see, oh, well, the find method doesn't actually find anything. All it's doing is creating a new query. So my next question is going to be, well, thanks, Mongo. What do I do now? Oh, sure. Yeah. Doesn't help, no. I'm not sure I can make this. Maybe I can do something like this. Cool. Is that high enough? Cool. OK, so I have this find method. It's returning me a moped query. What do I do with one of those? Well, this is the third Pry command I want to show you. ls shows you the list of methods on classes or methods on objects. So I can just ls moped query, and it shows you, well, here are all the things you might do with a query. So you can iterate over them with each. You can use one or first to find one of them. And so that's now what I'm going to do. So I just use the up arrow a few times. I'm back here. I can find one user, and that's fine. That's not actually the user I was looking for, though. If you notice here, it's not the admin user that I was hoping to find. Maybe if I get all of them, that will work, but still not. Doesn't matter. Mongo has a way of querying for everything in an array. So here, I'm going to look up everything in Mongo that has my name or my full name. And I run that, and Pry says no. Why does it say no? Well, if you look, you can see this $in has been highlighted like it's a global variable. And so it turns out you can't use the new hash syntax unless you have valid symbols. So we just go back old-fashioned way, use a string, and make that $in. And then finally, I find both the users I'm looking for. So here's the admin user with the full name. Here's the non-admin user with just my temporary name. So hopefully it was obvious that most of those things were deliberate. If you're in doubt, let me know later. And this is just the 3 commands I showed you. So this is the core bread and butter of using Pry to work out how to write code. I mean, you can just type lines of code in. I couldn't fit that on the slide in an easy-to-say way. But type in lines of code, watch it crash, fix it. It takes no time. It's even quicker if you're not trying to explain what you're doing as you're going. Then we have introspection commands. So ls wraps object.methods. It shows you all the methods. It groups them by which class they're defined in. It highlights them depending on whether they're public or private. And you can use ls-grep to find them with specific names. So ls is kind of the workhorse of Pry. In the same way, ls in bash is basically the workhorse of bash. Every time you cd somewhere, you write ls, and then you can see what's going on. $, otherwise known as show source, shows you the code, and $, or show documentation, or show doc shows the documentation. I find almost always show source is more useful. I'm not sure whether that's because people don't document very well, or just, I don't know. Ruby is easy to read, I think is the kind way of saying that. So those are the 3 things that, if you want to learn anything about how to use Pry more than it's just IRB, are the things you should remember. Yes. Yes, so actually, one of the funny things with the ls in bash is it has a bug filed against it, which is too many options, because there are 27 or so. Pry could probably do with the same bug. So you can give it like -p will show you more, -v will show you more, because by default we hide all the ones on object because they're the same for every single thing. Yeah, thanks. If anyone else has questions, I'm happy to take them at any point. So you can give them method names, so you can do like show source puts. You can also, if you know which class they're on, do kernel pound puts. And if they're on an object, you can do sort of $mongo.find. In theory, you can put any Ruby expression there, but the tokenizer is a bit weak sometimes. So generally, object dot is the safest. So let's say I want to define REPL. I just do that, and you can see my prompts change to have this star, which means, hey, you've started writing a Ruby expression. And then I can just do loop puts eval readline, and then you're done. So that just works. And you can see it's syntax highlighted it, it's indented it for me. I didn't have to type tab at all, it just worked. So REPLs are great, but, and this is kind of more into maintenance mode. So we have GitHub, they have an exception rate of like 8 in a billion method calls. I still don't know how they do that. They can't just be writing every line of code right, they must be writing it in a cohesive way. And REPLs aren't great for this. They don't keep a record of the things that you found that went wrong. If you try and change stuff, you have to test it again manually. And as your app gets larger and larger, it can be really, really hard to construct one line of code in a REPL that actually tests anything useful. And so the obvious solution to this is, well, let's use tests as well. And so the way I tend to develop is finding the solution in the REPL. I'm a really, really big fan of this because, as I said, 80% of the time when I write code, it doesn't actually work. So I can iterate really fast in the REPL, get a line of code that works, then kind of put it somewhere, write some tests that test what it should do, and then do all the wiring, which is basically all the code I have to use, have left to write. I'd like it if that let me write code that works first time. It still doesn't seem to always work. But it's a lot better than 80%. I don't know quite how much better. So when your code base gets large, you need to start thinking about maintenance. You need to start thinking about every line of code I change has the potential to break the entire app. Wouldn't it be nice if there was something automatically testing stuff? And that's exactly what tests are for. The test-driven development guys also really love the idea of designing your API via tests. Because if you start building an object by calling it, you end up with a much natural, more easy-to-use object than if you're trying to take the really complicated bit of code you just wrote and then build an API outwards. You end up with something much more ugly. And the third thing, and kind of subtle thing they're really useful for, is for documenting assumptions. If there's a test that says, when I pass nil in here, it shouldn't crash, that probably means that someone is assuming they can pass nil in. So if I break that, it's going to break something else. And I can then use the fact that it's been tested to try and find where in the code this is a problem. Tests aren't the be-all and end-all, though. So the least favorite thing I have with them is they're slow to run. Because this means they're slow to write, because they're just code. So 80% of the time, I write one, it fails for the wrong reason, or it passes when it should fail. It just doesn't work. And that means I'm having to run these tests over and over again. And if you're at the performance talk just now, they're improving it. But still, loading a Rails environment isn't going to be instant ever. And so it's these first two I want to fix. The bottom one I've just put in because it's annoying. But in theory, if you write really good tests, that shouldn't happen. Obvious solution. Let's use a REPL again. So Pry itself doesn't have integrations with individual frameworks. It doesn't really have any C extensions. Pry itself will run on Ruby 1.8. It will run on RBX. It will run on JRuby. But Pry Plus is where all the cool stuff is. So if you're running on Ruby 1.9 or Ruby 2.0, install Pry Plus, and you'll get a whole load more magic along with your Pry. And the two things I want to point out or mention explicitly are Pry Rescue Minitest and Pry Rescue RSpec. These things are kind of magic. What they do is when your tests fail, instead of having to wait for the other 452 tests to pass and then seeing the error message underneath, they just pause you right there and say, this test failed. Maybe you should look at it right now. It will save you time. We have it for mini-tests. We have it for RSpec. If other people are using better testing frameworks, we can talk about integrating those afterwards. How does this work? So I have a test file. I'm actually going to be testing that line of code I just showed you in the REPL. I run the test. It's going to fail, so Pry is going to open. It says, I expected to find 2 users. So here it's finding users, which is the line of code. This should find both the non-admin user called Conrad and the admin user called Conrad Irwin. But for some reason, it's only finding 1. I don't really know what the problem is yet, but the chances are it's inside the find user method. And so what I'm going to do is I'm going to add a breakpoint using the break command at the find user method. This means next time the find user method gets called, instead of running the code, it's going to dump me into Pry. So I've added that breakpoint. It's kind of verbose, but here it is, breakpoint on mongo.rb line 3. And you can see that's exactly where I'll stop. All I need to do now is call find user again. But I don't want to have to type stuff in manually because the chances are I'll do it wrong. So instead, I can just run try again. Try again comes from Pry rescue, and in the context of minitest or RSpec, we'll just rerun the failing test. That means you can just keep cycling over this test until it passes. You're not having to wait for the Rails environment to load. You're not having to wait for matches to be set up or anything. It's literally the smallest amount it can try again it's going to do. If you use Pry rescue with Rails, try again will rerun the web request. If you're using Pry rescue on just a standalone script, it will rerun the script from the start. So this is kind of the power, let's do stuff again and again and again to see when it breaks. I run try again, and you can see that my breakpoint's been hit. So up here, breakpoint 1 first hit, and then here's a little arrow that says, and you're ready to start debugging find user. I can use step or next to move the arrow down a line. The difference is step, if there are any function calls, would step into them so I could debug the subfunctions. Next is just walking over the top. And so if I do that again, I'm on line 6. Line 6 looks like the scary one, so it's probably the broken one. I don't want to step over it yet because I want to debug it. And so I can use the play command and just say play line 6. And what this is going to do is it's as though I stepped over it, but instead it's just going to run it and leave my arrow where it is. So indeed, we can see playing line 6 gives me only 1 user back. It's only finding the admin user. It's not finding that Conrad Irwin user I had before. And that's kind of surprising, because looking at line 6, that's exactly what we had in the REPL. Why is it broken? Well, I'm guessing the problem is names, because that's the only thing I've changed. And if I look at names, you can see, well, there's missing a space. So if I show you the source of the current method, show source with no arguments does that, you can see that when I added the first and last name together, I forgot you need to join them with a space. This is the kind of mistake I make all the time. I don't know whether you guys are just better programmers than me, but that's how it is. Edit is Pry's way of saying, OK, we found the problem. Let's fix it. So edit-m is edit the current method. And this is obviously very easy to fix. I just add a space in here. And once I've done that, the find user method is now fixed. Pry's reloaded it for me. I don't have to close everything and start it up again. Pry will take care of that. So all I need to do is disable this breakpoint on find user. I think it's disable the first breakpoint. And now I can stop debugging and just try again. And hopefully now the test will pass, because I've fixed the method so that find user actually works. And indeed, when I run it, that's true. So you can see I had 1 test, and it thinks no failures just because I caught them and rescued them for it. So the whole idea here is I ran the test once. I loaded Rails once. I loaded everything just once. And I was able to run several lines of code, fix the problem really interactively, and then move on to the next thing. If I'd had many failing tests, it would have just dumped me in Pry the next time as well, and then I could have fixed it. A few more commands this time. So the top few are from Pry+. Try again is Pry rescue, and it gives you this idea of let's rerun the tiniest bit that failed again. and see if it still fails. Then break is adding breakpoints. If you've used the Chrome developer tools or Eclipse or any other debugger, you'll know there are breakpoint support. You just say, please stop on this line of code. Pry, you just name a method. You can name a file on the line if you want to, and that will just work. Then step and next are for moving around once you've stopped the debugger. You can also use continue to say stop debugging now, or finish to finish the current function and go back up to the previous one. Play is actually core pry, and it's basically a copy and paste helper. I could have just copied and pasted that line into pry, and it would have had the same effect. But the chances are I'd have copied like that line number at the start, or something else would have gone wrong. So if I can use play, that's just more reliable. There's also the edit command. Edit is just magic metaprogramming, and I'm very, very glad that Ruby lets you do things like this. But we save the file, and then we read it again, and that causes the methods to be redefined. It causes everything to just get back into a good state. So it's really nice that Ruby lets you do that, and Pry just wraps it in a nice and easy-to-use way. So even with testing, stuff still goes wrong. So bugs just get through the net, either because they don't happen very often. Like GitHub 8 in a billion is very good, but it's not 0. And the problem with this kind of bug is they get really hard to find. They get really hard to fix, because the chances are they happen like only in production and you never see them. Or they happen if Mongo takes more than 5 seconds but less than 7 seconds to reply, or something like that. And you just have to use your ingenuity to find them. The company I'm working at now is Bugsnag, and we try and help you with this. So we're like, OK, we know you've REPL'd stuff. We know you've tested stuff. Everything's working in development. But still, some stuff is going wrong in production. And so what we do is when that happens, we send you an email. We say, hey, user Fred just requested this page. It crashed for him. This is what we think is why. And then we let you try and fix it yourself. How do you fix bugs that happen in production? Well, 3 steps. Firstly, reproduce them. If you can't reproduce the bug, there's no way you know if you fixed it, because you can't tell. And this is like a really difficult thing. This requires guesswork almost. You can just be, you can see what's gone wrong. You can try and work out from the request if there's anything odd happening. But in the end, you just have to try stuff and see if you can get the same exception. Once you have that, you then have to find the problem. So there's a big difference between the place where an exception was raised and the place where your code is broken. So even once you're reproducing an exception locally, finding the actual point of the problem can be tricky. Fixing it should be easy. Fixing it is just writing code. I've already shown you how to do that. You just use a REPL. You can then write some tests so that the code never breaks again. That's easy. You just use a REPL. So the thing I really want to concentrate on now is, how do you find the problem? And so this is the third and last kind of Pry show-off session. I have a file, run.rb, and when I run it, I get this exception, undefined method plus for nil. Anyone seen that one before? Right. And the worst thing about it is, that's not going to be where the problem is. So this exception is happening on line 5 of mongo.rb. So let's have a look. Well, this is the method we've seen before. This line is crashing. For the purposes of today, I'm just going to add a binding.pry, because I wanted to show you guys this. In real life, I would have just rerun the command with rescue instead of Ruby, and that would have intercepted it with pry rescue, just like the mini test example. But here's how you do stuff manually. So if you put a binding.pry in, this is going to open pry on the current binding. Bindings are magic Ruby objects that just encapsulate the currently running code. So this binding has access to names, it has access to self, it has access to everything that running code has access to. And there are kind of 3 uses for binding.pry. One is finding why exceptions failed, which is what we're going to see now. Another is for understanding code. If you have some complicated algorithm, and you can see the inputs coming in here, you can see it's returning the right result, but you still don't know why, if you add a binding.pry in, the chances are you can print out the values from inside pry and just get a feel for what the algorithm is actually doing. The third use case is kind of edge casey, but I've used it a few times, and it's good fun. Have you ever been implementing something, and you're like, I wish someone else had implemented that other method? Well, what you can do is implement the method, but instead of writing the code, just put a binding.pry in. And then when that subfunction gets called, you just return the right value from pry. and the calling code can continue to run. So in that way, you can kind of debug one function, even if its dependents haven't been written yet. But for now, we're just going to use the first use case. Something is going wrong on the next line, and I want to know what it is. So I'm going to add a binding.pry in just before it crashes. If I run.rb again, instead of crashing, it now opens Pry. And I can show you the play command again. If I play line 6, as it is now, I get this crash that I've seen before. Undefined method plus for nil class. Well, OK, that was great. But how am I going to debug this? Clearly, first is nil. Something is wrong somewhere else in the code. And this is where Pry Stack Explorer comes in. So the up command is one of the methods that it provides for accessing the stack. So programs are all organized into call stacks. It starts at the top, and then each thing calls down into the function below. So if something is passing nil down the stack, we want to go up and have a look at what it is. We can just run up. And you can see now I've moved to line 5 of run.rb, and something is calling find user with request.firstname. I would reckon that request.firstname is going to be nil. And indeed it is. Why? Well, I don't know yet. I'm not inside request. So you can use up and down to move around the call stack. And then you can use CD to just move around sideways. So I've moved up one level, and now I'm going to move sideways into request. CD comes from bash, same as ls. You should feel familiar with them is the idea. I CD into request. Out of habit, I run an ls. And you can see that there's a first name and a last name method. There's this crazy pry method, which is just pry internals. You can see it has an instance variable at data, and then there's all of these local variables. As a general rule, anything that starts and ends with an underscore is pry-related, and this is no exception. I want to highlight 3 of these which are useful, and the rest you can pretty much ignore forever. So let's say I do something like 7 plus 8, 15. That's great. Now, in the next line, I want to reference that output, 15. I can just use underscore instead. And underscore is going to be 15 because it always refers to the last output. Underscore is there because sometimes you just want to go one before. It does the same thing. You can use underscore out underscore to get further back, but it's a bit complicated. The other useful one, however, is underscore x underscore, which is the most recently raised exception. So there's actually the thing we're trying to debug right now. And you can do things like get its backtrace, x.backtrace. But because that's a really common thing to do, Pry actually has a command to help you. And chances are exceptions annoy you a bit. So if you just run WTF, it gives you the first 5 lines of the backtrace. There you go. Anyway, we were debugging this thing. What's wrong? So the first name method is returning nil. Why? I don't know. Let's look at the source code. So there's $ again, or show source. It's just going to let me have a look and see what's happening. Well, the first name method is just reading the first name out of the data. That looks fine. The only thing that could possibly be wrong is if first name isn't in data. And if you look, you'll see I've committed kind of the cardinal Ruby sin. These are strings. That's a symbol. It doesn't work. Yeah, my least favorite thing. I can use the edit command. It takes a method as well. Edit-m would be the current method. If you give it a first name method, it will edit the first name method. And then I can quickly fix this. I see last name has exactly the same mistake. And so now I fix these things. Pry's reloaded them automatically. I can call first name immediately. There you go. It's fixed. So I'm done debugging. I can cd back out again, ... straight from bash. And then what was I looking at? Where am I is going to just show me where I am. So if you've done a lot of CDing around, it gets hard to keep track. If you've moved up and down the call stack a few times, it's hard to keep track. So where am I? It'll just get you centered back again. Yeah? Do you have show stack installed? I think there's you call a thing called Pry backtrace, which is just where you opened Pry and the backtrace up there. So here it will be not paged, but that's essentially what it does. Yeah, and it will do that. I think that's the best command for using it. So if I ran where am I, it's showing me I'm here. I can run down, and then I'm back into find user, and this is where I was. Now, I'm going to remove that binding.pry. This is one of the bad things about pry. If you forget to remove it, it's just going to pause and wait for you forever. So I removed binding.pry. This program crashed because I didn't fix it fast enough. It had already called find user with nil. But now, when I run ruby.rb, it's going to print out my email addresses. So it's fixed. And I had to run it once. Luckily, this would have been a really quick script to run over and over again. But imagine if that was something in a Rails initializer or something else that's going to take 10 or 15 seconds every single time you run it. It gets frustrating. Quick recap of the commands I've shown you. Binding.pry, not really a command, but the raison d'etre or raison d'etre of pry. So this was the reason that John Mayer was like, yeah, we need to share this code. If you can open a REPL anywhere in your app, it enables so much cool stuff. You can understand things, you can debug things, you can even just intercept it and return manual values. Then there's CD. If you want to look inside an object, if you want to call private methods, if you want to get at instance variables, CD into the object, it will let you do whatever you like. It's as though you're running code inside that method. Up and down let you move around the call stack. If you have a nil bug, chances are it's not doing nil plus in the code. Something has passed a nil in. And so being able to move around the call stack lets you debug stuff like that. If you've been using those three for a while, where am I? We'll show you where you are. I didn't actually show you the help command. We touched on it earlier. But if you're inside pry, and you're like, I wonder what pry can do, try running help. And shield your eyes a little bit, because it goes on for a while. But the basic useful ones are at the top. Here you've got CD, you've got ls, here you've got pry backtrace that I just mentioned. Then there's various other things. Where am I? WTF. The more question marks you add to WTF, the more backtrace it gives you. And then various commands for dealing with source code, edit, play, et cetera, et cetera. Right down at the bottom, you'll find that I have, when I get there, various gems installed. These almost all come from the Pry Plus package. So there's more documentation. Pry Plus gives you documentation for Ruby syntax, as well as standard library and gems as well. Pry EM is just event machine integration. If you guys are using event machine, that's pretty useful. Git lets you do Git operations based on methods. And then the two at the bottom are the real meta-programmy ones. Catch unhandled exception and move around in the call stack. So in summary, you should be using a REPL. If you're not using it at all at the moment, then use it a little bit. If you're using it a little bit, use it more. It's not going to waste time. The chances are when you write code, it actually doesn't work. And so if you can get very, very quickly to a point where you have confidence in the code, that's going to save you time. I also like to think that it improves the quality of code. If it takes no time to write a line of code that works, you have no incentive to go, well, I'm not going to touch that code because it's scary. You can just fix it. And in that way of just really getting in touch with your code base is very useful. It's obviously also a lot of fun. If you're going to use a REPL and you're using Ruby, you should use Pry. IRB is OK, but Pry has color and commands, and it's robust, and it works. And that's about all I wanted to say. Thank you very much.